And here we go, guys, the final set. So as always, if you guys haven't seen the previous 19 questions, there's a playlist in my description section right below, and it should cover everything. So just click on it and you can view from 1 to 19 right now. But for everyone else, let's jump right in. So the histogram shows information about the birth weights of some babies. Okay, now just notice it carefully, guys, yeah, that you're not given any frequency density. If you're not, the safest thing to do is just to, work algebraically. So for example, you can see that there's like a height of like 4 blocks up, yeah. So let's just work in ones, yeah. So there's 4 blocks up, so this could be a height of 4x, yeah. And that means this major bar is probably 10x, 15, this is probably 20x, yeah, just counting, and this is 25x right at the top. Okay, now when you want to work at anything, it's always base times height. That'll give you the whole area of the shaded region, yeah. We're gonna come to that anyway. So it says here that 6 of these babies had a birth weight of less than 2.5 kg. So here's less than 2.5, this is this region here, or greater than 4. So okay, so we know that the purple region is equals 6. So just doing the maths right now, yeah, the area of this purple region is going to be base times height. So it'd be a distance of what, 2 to 2.5, so it's about 0.5 times 4x. So 0.5 times 4x, in the calculator will give us 2x. And the area of this purple region, well, it's a width of 1 and a height of 1 block, so 1x. So it's 1 times 1x, which is 1x. So 2x plus x is 3x. That means 3x must equal 6 babies. And that means essentially dividing by 3, x equals 2. So I should get rid of the baby sign, that's the area. So that means this x value is 2. So we're actually going up in, let's replace x with 2. So it's going to be 8. So it'll be 2, 4, 6, 8. So that's it, we found our frequency density. Every little square is worth 2 units. Done. Now let's go back to the question. So it says work out the number of babies who had a birth weight between 2.5 kg and 4 kg. So that's literally everybody else. Let's do this, yeah? So let's work out the general area in algebraic terms. Plug in the 2 and you're done. So the area of this block here, between 2.5 and 3, is a what? 0.5 across and 4x high. So it will be a total area of 2x. This middle block here is, oh god, that block is ugly. So it's 0.4 across. It's got a height of 20x. So 0.4 times 20x. So 0.4 times 20 is 8. So it's 8x. This area is 8x. Now this skinny block is 0.2 across times 25. So 0.2 times 25 is 5. So this is 5x. This skinny block is 5x, yeah? And now this little medium box. So again, 0.4 times, I think it's up to 15, isn't it? So 15x. So this is 0.4 times 15x. So what's that? 0.4 times 15x. That's 6x. Okay. So now we just add up all these x's. So you got 2x, you got 10x, 15, 21x. And then because we know x is 2, this is going to equal 42. So we have 42 babies between this way. Alright, number 21. Now these kind of problems, and this is very specific, if they use the word show you're working clearly, it does not mean just, put this root 45 in the calculator and then root 20 in the calculator individually. No, because with these ones you need to actually demonstrate the method you use. Now here I recommend that you use something known as prime factorization, yeah, or factor trees. So the way I'll do it is I'll take root 45, break it down into 2 pieces. So we can say that 45 can be made by timesing 5 and 9, so root 5 and root 9. So you're going to keep on going down until you get prime numbers. So 9 becomes 3 and 3, and you're done. Because why? You can say that root 3 times root 3 will give you a whole 3, because 2 thirds give you a whole, and then you still got root 5, so root 3 times root 5 is 3 root 5. And that's one of them. And then you're going to repeat the same process for root 20. So 20 is the same as 2 times 10, both rooted. And 10 is the same as 2 and 5. And just like the previous one, when you got 2 the same thirds, they become a whole. So 2 and 2 become a whole 2. Meaning we're left with 2 root 5. 2 root 5. And now combining these two guys, yeah, so 3 root 5 plus 2 root 5 is going to give us 5 root 5. and you're done. That's it. Okay, now for part B, we need to express this fraction into that form. Now, they'll never use this word, but the key word here is to rationalize. I'm not gonna lie, there is a little nice technique how to do this, thanks to your calculator actually. So the first things first, let's rationalize, yeah? So rationalize means, at least denominator, means to clean up the bottom, get rid of the third. So, and to do that, wherever we have the bottom, we copy up and down, yeah? And we flip the sign to a plus. If it was plus here, we flip it to a negative. Okay? So let's put that there, and then just, for convenience sake, just write like that. Now all you want to do is at least solve this line of working, and then when you do that, and it's sufficient enough, you can actually smash in the calculator, and it will give you the simplified form automatically. So let's do this. So 2 times these lot will give us 2 root 3 plus 2, nice and easy. As for the bottom half, well, it's going to be a quadratic, yeah? So root 3 times root 3 will give us a whole 3. Root 3 and 1 will give us plus root 3. Minus 1 times root 3 is minus root 3, so these two cancel out actually. So let me just leave as 3. And finally, minus 1 times plus 1 will give us negative 1. And that's it. Now, if you guys want, you can literally put this in a calculator because it's actually fine at that point. And doing so, you should get 1 plus root 3. You should be done. If you're not sure this is right, go back to your fractions and copy this down in your calculator. And if you do that, 2 over root 3 minus 1, you get 1 plus root 3 as well. So even this gives you 1 plus root 3. That's it, you're done. So this is one way to verify if you guys are happy with your answers, yeah? Anyway, let's move on to C now. Oof. This is the main one. So express this form into something known as completing the square format, yeah? Now, it's not as bad as it looks, I'll tell you right now. Now, the key idea is firstly copy this down over here, and then follow these immediate steps, yeah? So in order to complete the square, I always recommend that you underline the first 2 terms, yeah? And then we ask ourselves, what is half of 6 root 2? Well, you can always divide it by 2 in a calculator, but generally speaking, we always write x plus half of this would be 3 root 2. And then we wrap it around in a bracket and make it look like a square. So that's what it looks like. So when you got something like this, it's always going to be x plus or minus half of that term. Now, at this point, you're going to copy the rest. So copy the minus 1 and then subtract this lot squared. So it'll be 3 root 2 squared. And you're done. Now, all you want to do is literally put this all in the calculator, yeah? So put minus 1 minus 3 root 2 squared. I'm doing it at the same time, guys. And I got minus 19. And that's it. So the final answer is going to be x plus 3 root 2 all squared minus 19. So it says that we got, and I'll explain these properties if you're not sure. So we've got A, D, B, and E, which are points in the circle with center O. And you've got these lot, which are straight lines. So we can see it here, 3 different straight lines. A to C, C to O, and O to D. We've given measurements too. It wants us to work out the value of x. Okay, so one thing to note is that for any unlabeled side, it's important that we label it. So for instance, O to E is actually a radius. Why? Because O is the center, and anything that hits the circle is a radius. So I'm going to call that R. And one thing to note, O to D is also not fully labeled. So if we know that part of that radius is 2, that means the remaining part, we can just call it R minus 2, yeah? Just to keep the notation minimized. You don't want too many unknowns because you already got X. Now the point of this question is that we're going to have to solve R and X simultaneously. So we need 2 equations. That's why you got internal intersection method and external intersection. Now let's see how this one goes, yeah? So first things first, I'm going to use the internal intersection. Oh man, yeah, I got a terrible cough here. Awful. So internal intersection. So it says here that if you go across any chord such as M and N and I and J, we can say that M times N equals I times J. So look at this diagram, we can see we got, for example, A to B, yeah? We got 7 times 4, so that's 1 bit. And that must equal, and this is the weird one, yeah? So you're looking at D to O, But then you also got that it doesn't carry on. However, we know that it's going to be a radius that goes along. Why? Because you got O to E. So if you just imagine that we just like carry this on right across here, that would be another extra R. So in essence, we have a full length of R plus R minus 2. So we're going to have this full length all the way across, valued at 2R minus 2. Okay, so let's just keep that in mind, just for the sake of this question, yeah? So essentially, we're going to have, therefore, 2 times 2R minus 2. That's going to be the part where it crosses. And when you do so, you can easily find R, yeah? I'm going to quickly solve R. Okay, so you get 28, divided by 2 is 14. And R is going to be, just give me a second, plus 2, divided 2. So the radius I got was 8. Okay, so that's my radius here. And now, that's cool. So we can update these results. So this is going to be 6 here, and this is going to be 8. And it looks quite legit for now. Okay, so moving on forward. Now, as for the second part, external intersection, this is where it gets a bit more tricky as well, possibly. So we have to look at it this way. So it's going to be A times the full length, which is equal to this short length times the whole length. Now looking over here, we can start at point C. We got 5 times the whole length. So let's do it here. So 5 times the whole length, which is 5 plus 4 plus 7, so that's 11, that's 16. 5 times 16 equals B, so B is x. And we're going to multiply that against x plus this radius 8, and if we extend it across, another 8. So because it's a radius, it's a circle. So we've got 8 plus 8, so 16 plus x. That's it. Now it looks like, okay, now it looks easy. So now we just solve for x. So let's have a look at that. So let's have a look. So 5 times 16, come on, that's 80 equals 16x plus x squared. Right, so we have a quadratic equation, yeah? So just make it look into the usual format. So make it all equal to 0. And now we're going to go ahead and try and find the roots here. So, by the way guys, if you guys happen to find a faster way, please let me know so I can update this video in the future. Okay, otherwise, if this is right, then, you know, that's all good. So using the quadratic formula, it would be minus b plus minus, and remember the quadratic formula is in the front of the booklet, yeah? B squared, so 16 squared minus 4 times a times c all over 2 times a. Okay, ooh, let's see what this gives us. So we're going to get minus 16 plus, and I'm going to use the plus result, yeah? Only because I think the negative will definitely be wrong, because you can't have a negative length. 4 times minus 80 over 2. And okay, and yeah, I think it's legit because I got x value of 4. That's it, and I think this is the final answer. And because it's 6 marks, I don't know, I mean, it seems like a lot of work. But anyway, guys, if this is right, you know, thank you. But otherwise, then yeah, I'd like to hear your comments on this one and what you guys think about these methods. But otherwise, let's move on to number 23. And finally, guys, number 23. Whew. So after the beast of a question on the previous one, man, this one is a lot better. Not easy, but a lot better still. Let's have a look here. And oh yeah, this formula here is from the front of the booklet, yeah? And this is known as the sum of the first n terms, okay? This is the summation formula. Now, let's have a read. So we've got the sum of the first 48 terms of an arithmetic series is 4 times the sum of the first 36 of the same series. So what's that saying is that the sum of 48, when n is 48, is equal to 4 times the value of the sum of the first 36, which makes sense, I suppose, for whatever reason. Now, it wants us, with this equation, to find the sum of the first 30 terms of this series. Okay, oh man. Now, all you have to do here is literally just copy this equation twice, replace n with 48 here, and then again, on the right hand side, replace n with 36. So let's do it. So for the sum of 48, we're going to have 48 over 2 times 2 times a. And by the way, a is known as the first term, by the way, if you know even if we know what it is, and d is the common difference. We have to figure out what these two are, I'm guessing. Alright, this is going to be equal to 2a plus, so n minus 1. So because 48 minus 1 would be 47d equal to 4 times So S36, 36 over 2, I'm just going to make it quick, which is 18 times 2a plus 35d. Okay, and then 48 over 2 is 24. Alright, so it looks like we have two non-similar equations, I guess. Right, now, what do we do next? So now we got all this information, let's go ahead and see if we can hopefully tie this up, yeah? So expanding the bracket, you're going to have 48a plus, what's that, 24 times 47. Okay, so you get 1128d. That's equal to, sorry, for this one you want to do 4 times 18 first, just to avoid any error. And that should give us 72. 72 times a is 144a plus, now 72 times that I don't know in my head, so it's 2520d. Alright, so at this step you're probably thinking, what should I do next? Okay, well, first things first, let's go ahead and collect like terms. Yeah, let's subtract these two across, and doing so I already did it and I got 0 equals 96a plus so on. Okay, so that's fine. However, that's not it. We can also, you know, I thought, okay, let me just find an expression for the sum of the first 30 terms. And doing so, I got this. So that's also easy. Now, at this point, this is the part where it can really confuse you. The question is actually just noticing that all of this actually equals 0. So possibly we might need to factorize this to make it look like the S30. And the question is, how do you factorize it now? What term to pick out? Well, my tip is to probably see if it's possible to get some number that leaves you with 2a plus 29d. I mean, if you can't do that, then the question is a fail. There's nothing we can do. So the only way to do this, and I'm not looking at this number, but I'm looking at 962. To get 2 left inside, you would have to, well, divide it firstly by 2, and you'll notice that you would have to divide it by 48. Just see if this is possible, yeah? So let's have a look. Dividing this 1392 by 48, and I haven't even tried it, but let's see. You get 29. So in fact, all of this one is divisible by 48, and that means that all of this is equivalent to 0. So actually, you know, just ignore 48 because you can cross it out now. 2a plus 29d is 0. That means this is 0. So 15 times 0 is 0. And that's it, guys. We're done. That's the end of the question. You know, one rule of thumb is, yeah, sometimes if you don't know what to do, I'm telling you now, just put 0 or 1. And at least, you know, 9 out of 10 for those really hard ones, you could be right. But anyway, guys, thank you for watching. I hope you enjoyed my video and some of the basic commentary. And yeah, let me know if there's any like mistakes or any doubts or questions you guys have, and we'll go over it. But otherwise, thank you for being here, and I shall see you guys next time. Ciao.